All right, so my name is Hermanni Toivo, and we're going to be talking about how do we find the right use cases for AI, because that, I think, is a real challenge. There's a lot of hype on what you can do with AI at the moment, but we have to think about, okay, what is AI actually good at, and where are the potential use cases for that? So who am I first, though? My name is Hermanni Toivo. I'm a Salesforce CTA, and I have experience of over 8 years from various architect roles and Salesforce roles. And I think for the moment, I'm the only CTA in Finland outside of Salesforce itself, although that might change in the next few months. I know for a fact that there are people trying. I've done several AI implementations, both using Salesforce and not using Salesforce-based technologies. And basically all of them are very similar when it comes to how the technology works. So, what do good use cases of generative AI have in common? Any thoughts? Anybody in the audience? I can see it's Monday morning.
Well, simple.
Simple?
Simple, good data.
Good data? Okay, good data is a good one. Yeah? Any other thoughts?
Strategy and planning are both, in my opinion, good. They work well with generative AI.
Can you elaborate on that? So strategy and planning work well with generative AI.
Either way, you say, for example, this is my starting point, this is my goal, help me, devise a plan to get from A to B. It's really good at that.
Yeah, so coming up with a plan of getting from A to B and like, okay, yeah, that's a good use case.
Yeah, or even, strategy like help me form a strategy to take forward this kind of company, or, what would be needed to go to this place in the market or something.
So
like
you can use it to generate ideas, basically. Yeah.
Basically, really well. Yeah.
What would be some tasks that generative AI, some other tasks that it's good at?
Summary.
Summary? Okay, summary is actually a good, yep.
It's many like
Creative work.
Many different kinds of content generation, especially nowadays, multimodal kind of content generation.
Yeah. What I would say is a good general bird's eye view for looking at the answer to this question is it involves converting between structured and unstructured data, or between unstructured data and a different form of unstructured data. And all the examples that you just listed are somehow implementations of this. So for example, asking for a summary on some piece of text, that's conversion of unstructured data into different unstructured data. You could ask it to, for example, take an email and put that into some information system with whatever schema. That's an example of going from unstructured data to structured data. Whatever task you give it, this is, I would say, the common denominator for all those tasks. You're converting unstructured data unstructured data or structured data into unstructured data. Basically, you're going through all of the conversions except structured data to structured data. Now we're going to talk a bit about what each one of these is. So, for example, if we think about the differences between like what traditional computation is good at and what artificial intelligence is good at. If we have and I'm talking here about generative artificial intelligence. If we have a structured input and we want a different structured output, it's very likely that we're going to be applying some sort of algorithmic processing where it's very rigid. And for that case, you do not want to use artificial intelligence. You're probably not going to end up with the same result every single time given a certain input. Whereas if you want to convert between other types of data, such as unstructured data to structured data. This example of an email message being put into like a customer service platform, or a user using chat as an interface to, for example, make a booking for a restaurant. Those are sort of prime examples where this is at play. And if we look at what an example agent would do, here we have a user that is requesting to book a table. So when they send a request to book a table via a chat interface, right? That message that they sent via the chat interface, the agent tries to identify the intent of the user based on that message. So that might be a conversion of the data of the user into structured or unstructured format, depends how we've architected the agent. But when the agent has to actually decides that, okay, now I need to call the API of the system that actually manages the bookings, the agent needs to transform the input of the user to make that request, which is unstructured freeform text, and it needs to transform that to the right schema accepted by the booking API in order to proceed forward. Likewise, when the booking system responds, hey, book the table at this time, that response that probably comes in some sort of JSON or XML format needs to be taken into natural language for the user to be able to understand it. So that's why, going back here, that's why the generative AI is powerful compared to the traditional approaches, is because now it opens up this ability to process unstructured data in different ways compared to what was previously possible. Of course, there's different types of unstructured and structured data. It's not, a black and white thing. It's a continuum where some of the data is really structured, very rigid, and some of the data is much more free-form and much more abstract and much harder to, in that case, to get structured. So where traditional computation works is here. You can go into the other stuff like a PDF or written list with traditional computation as well. But what those would require then is you'd want to have the same format, same schema. You wouldn't have PDF documents that have all different kinds of formats, all different kinds of content, and be able to use traditional computation on that. You could still do some applications using traditional computation on them, but you wouldn't be able to do the kind of summarize this document applications. Whereas if we think about what we can do with generative AI is more on the whole spectrum. But if we want to, for example, convert from XML to JSON, I probably would not use generative AI for that, unless it's some really totally irrelated schema that we're converting in between that is not sort of algorithmically mappable. So it's not sort of black and white. There's a bit of, you have to understand what kind of data you're dealing with and what kind of structure the data has and what kind of structure we need to convert between the different formats that we need in our use case. By the way, feel free to ask any questions already now in case there's any.
Yeah, one I had on the previous slide where you had the flow between the agent and decide which course of action to take and these kind of things. So I would be interested in hearing you talk a little bit more about like what's in between those two blocks.
All right, reach out to me after the session. We can talk in more detail about what's in, because yes, that's a simplification of what happens in the background. There are whole complex processes of what the agent actually does in terms of avoiding all kinds of hallucinations or making sure that everything follows the guidelines. Any other questions or comments? All right, let's move on. So then the other question is, what else is like a sort of turn off of AI? What is it not good at? And we went over this sort of, if we need to do this kind of algorithmic processing where it's deterministic, that given a certain set of inputs, our agent should produce a certain output. That is usually where an agent is not good at. Now, this doesn't mean that if, for example, given a set of inputs, so user says, I want a table next Friday at 5 o'clock, that given a user says that we need to reserve a table at 5 o'clock. What this means is the inputs here means in terms of, because the user can phrase that in various different ways. So the inputs that the user gives in that case are not fixed. The inputs of next week at 5 is what we're thinking of as a fixed input. So if we have some sort of API that we're hosting where you can send a time and a table number to make a reservation, that I would not have running generative AI. But the user interface itself, which then calls that API, that can be running generative AI, because there we're not having this kind of deterministic processing. If we need transparency into what actually is going on in the decision making in the process, that's usually a reason of going with other ways of processing than generative AI. This would be, for example, if we have governmental official decisions that need to be documented as to why a particular decision was made. Of course, there are ways you can accommodate for that by, breaking it down into smaller decisions. But still, there are difficulties in dealing with that. If there's strict performance guarantees that we require, because using artificial intelligence to process, it's computationally a lot more expensive than the traditional if-else type of processing. So if our computational resources are not abundantly available, then probably we should think about other options. And kind of similarly to the second bullet point is the fourth bullet point about what happens if we require an application of human values, human empathy. An unchecked agent is not very good at doing that because it follows the instructions it's been given, and it's very hard to give it the comprehensive instructions of a complete moral framework. We're not there yet. And if the cost of being wrong is too high, so let's say we're giving the agent the ability to draft contracts for us on our behalf that users will then accept. The cost is very high if the agent makes a mistake there. Now we have legal obligation to follow that contract. Potentially. There are cases where we wouldn't, but the general rule is we would. And that means the cost of being wrong might be too high. So maybe let's not have the agent draft contracts for us without somebody checking it first. So guidelines for finding the use cases for artificial intelligence. Ask yourself the question, where would we need to convert between structured and unstructured data, or unstructured and unstructured data, or structured and unstructured data in the organization? And what are the processes where this is being done manually, and where is it being done at large scale? So that's why, for example, a classic process of where generative AI and agents are being proposed and are gaining ground is in the customer service function. Because in the customer service function, if a customer sends free-form text via some chat or via an email or via some other interface, we need to process that free-form text in order to take certain actions on it, input data into other information systems, query information systems. It's a prime case of where of fitting these criteria. And you wouldn't you don't really start thinking about, okay, when is the conversion between the structured and unstructured data? Where is that happening? If you don't map out the process of, okay, what are we actually doing in the organization? And map it out at the level of user inputs free-form text somewhere. Because if it's just, oh, user just contacts us and then we process it, based on that high-level description, you don't know whether or not those conversions are happening. You need to analyze it from the perspective of, in this process, where are we converting data and in what ways? And it might not be intuitive at first, but a human taking in a support ticket that comes in, a human customer service agent, and inputting data in some other system to refund the customer, for example. That's an example of a data conversion. The conversion is the information that provided in the ticket by the actual customer. That's being converted into a refund in the refund system. So that is an example of data transformation, not in the traditional sense, but it happens in the process and it's being done by a human. Yeah. So the first step is then map out the process of how this happens in your organizations. What are the different processes where we are processing data manually this way? And where are those numerous? And then the final point is the task something that's not on this list of don't do with AI? And that's how you find the right use cases. Look for these conversion points in the different processes. Make sure that to find the high value use cases, find the ones where it's happening at scale, manually by users, and make sure that it's not on the list of things that AI is not good at. If you want more detailed guidelines, you can email me, and I will send my template for analyzing different use cases and the questionnaire for that. Thank you.